today we're going to take a look at lesson 1.4, which has to do here with angle measures. So our objectives: we'll measure and classify angles, and then we'll identify and use congruent angles and the bisector of an angle. Okay. So a blank is a part of a line. A ray, okay, is a part of a line. It has one endpoint and extends indefinitely in one direction. They are named by stating the endpoint first, so you've got to use the endpoint first and then any other point on the ray. So if we were to name this ray that we see here, again, the endpoint of the ray is M, so we state that first, and then we choose one of the other 2 points, so we could choose O or P. We'll just go with O. And then the notation, you've got to use no arrow over the M and then an arrow over the O to show the direction of the ray. Okay. Again, we could also name this one MP, ray MP, because that just uses another point on the line, or on the ray, excuse me. But we have to use the end point of the ray. Okay. If you choose a point on a line, that point determines 2 rays called opposite rays. Alright. Opposite rays. These rays are collinear, so here we could use point J. We could pick point J, and we'll say that, so if we're choosing here point J, we could say that JH, that ray, and JK are opposite rays. And that's just with points on lines, you can pick them. Alright. Again, notice we used the end point of the rays to name those rays. We couldn't say, we couldn't say HJ and KJ, for example. Okay. We also don't say, excuse me, lost my train of thought here. We can't say HJ either and go with that. That notation, neither of those notations work for rays. Okay, so that's just, we've got to use the end point of our rays. So we've got to start with J. Okay, it's a big point to make. Alright, an angle is formed by 2 non-collinear rays. So 2 rays that aren't on the same line form an angle. So an angle is formed by 2 non-collinear rays that have a common endpoint called a vertex. So the endpoint of both of these rays is what we call the vertex of the angle. The rays are sides of the angle. So you can see here, this angle that we have, angle 3, the vertex is that point X. It's the end point of the ray XZ and the ray XY. Again, the rays are called sides. The end point is what we call the vertex. Okay. And we can name angles a lot of different ways, but we always need to use that symbol for angle. So we could call this, you heard me call it angle 3. That's the number that's inside of the angle. We can name angles just by their vertex. Okay. We could also name it using 3 points. When we name the angle using 3 points, the vertex must always be in the middle. So we could go ZXY. We could also go YXZ. Okay. But when we name it using 3 points, the vertex must be in the middle. Alright. So that's how you name angles. So an angle divides a plane into 3 distinct parts. So here we've got angle M that lies on our plane, and it's divided into 3 parts. Okay, the first part being the angle itself. So points that lie on the angle. So and when we're talking about the angle here in this plane, we see angle, let's name it using 3 points. So Q, vertex in the middle, M, and that's the angle we're talking about. And then we have the interior of the angle, and that is that darker shade we see there. and that includes point S and point R. And the lighter shade is what we call the exterior of the angle, and that includes points P and O. Okay, so those are the three parts of an angle. Use the map of a high school shown. Name all angles that have B as a vertex. So I'll use the numbers here. That's my favorite way to name angles. So if we're looking here, we're looking at point B. What angles have B as a vertex? I see angle 1 and angle 2. Okay, 3 and 5 are there close to point B. However, B wouldn't be the vertex of either of those angles. C is. So name the sides of angle 3. So here we're going to go and we're going to observe angle 3, and it has two sides. It has side CB, that's one of the rays, and then it has side CE, that's one of the other rays. So again, we call that CE was one ray, and the other was CB. So the sides of angles are rays. Okay, CB we could have also named C. I think that's point A that is up there. Yeah, CA as well. So either would have been acceptable there. Alright, so what is another name for angle GHL? So let's find point H because that's our vertex of the angle. So G, so here is point H. So GHL, we're talking about this angle. Another name for that would be angle 7. Or we could name it just using the vertex, angle G. Guys, maybe make note of this. You can't name an angle using the vertex if that vertex is a vertex for multiple angles. So keep that in mind, I guess, as well. Like, for example, angle B has two angles that it is the vertex for. So we couldn't just say angle B in this example and know exactly what angle we're talking about. Okay. Name a point in the interior of angle DBK. So let's find angle DBK. Let's highlight it with green maybe. So we start at point D, we go to B, the vertex, and then K. Okay, so what point is in the interior of that angle? So the interior of that angle, I'll use red here to color, is this piece, and it appears that point E is in the interior there of the angle. Alright. So that's just using parts of angles. Angles are measured in degrees. That's the units we use for our angles, okay? And if we take a look here at a protractor, notice, okay, if we're going to measure this angle, I'll use blue, angle FED, okay, you'll want to line up the bottom, the middle of your protractor there with the vertex of the angle. Okay, and so once you've done that, once you've put the middle of your protractor on the vertex, then you should be able to line up this edge of the protractor with one of the sides of the angles, as they've done in this example. Okay. Then by observing where the other side of the angle goes to, okay, on this scale that starts from 0, which is the inside scale. Okay, it's 0 here, and then it goes to 10, 20, 30, 40, and then it goes all the way up here to 50. So this angle, FED, would be 50 degrees. Okay, and so you can do this with any type of angle. Okay, want to just make sure that you align the 0 on either side, because notice there are two scales. This note talks about it. There's two scales running from 0 to 180. There's that inside scale, and then there's also on this side, it starts at 0 here and goes to 180 going that direction. So make sure you know what scale you should be using, whether you started at 0 on the right or 0 on the left, okay? So you can measure either direction. Right, angles are classified by their measure. Okay, so there's 3 different classifications here. Okay, if an angle is equal to 90 degrees, we use this little box in the corner of it to signify that. And we call those right angles. So this would be a right angle. It's equal to 90 degrees. Okay. If our angle is less than 90 degrees, we call that acute angle. And then if our angle is greater than 90 but less than 180, we call that an obtuse angle. So those are our 3 different classifications of angles, and it's all based off of the angle measure. So copy the diagram below and extend each ray. Classify each angle as right, acute, or obtuse. Then use a protractor to measure the angle to the nearest degree. So guys, this just wants us to be able to look at it, and we should be able to classify them as right, acute, or obtuse. Okay. Remember, right angles have that box, so it looks like there is one right angle there. Maybe that's angle MJP, which is the first one we're looking at. Yep, angle MJP. So start at M, go to J, then out to P. So that angle, that's the one that has the box. So that is we can classify that as a right angle. Okay, all right angles are 90 degrees. So we don't need to measure that one with the protractor. Okay, so the next angle we're talking about, LJP. So we start at point L, go to J, and then to P. So that is the angle we're talking about. That is bigger than our 90-degree angle. So recall that angles that are bigger than 90 degrees, we classify those angles as obtuse. Okay. This wants us to use the protractor, and so you guys are going to have to bear with me just for a minute. I'm going to get the protractor up here, and I haven't used this on the board in some time, so maybe a little bit of patience as well as we go through this. Okay, so to measure our angle LJP, again, we want to put this point of the protractor on that bottom edge. We want to put that right on our vertex as close as we can. Okay, and then one of the sides of the angles, you guys can see that side, the JP ray, comes out to 0 on the inside scale. So where does that other ray go? Where does the J, so now we want to look at where does the JL ray go on the inside scale. And if we look, I'm going to try to, it's not going to let me draw all over, it's going to drag. So let's extend this ray a little more so that we should be able to, okay, once I bring my protractor back down, yep, the ray does extend out to that scale. So, and where does it extend to? If I drew a little straighter line, I think that it's going to go right through the 105 degree mark. So this is 105 degrees. So that's how you can use a protractor to measure an angle. I'll have some in class tomorrow that we can use for our homework. Okay. Alright, angles that have the same measure are congruent angles. Okay. Congruent angles. So, if we look here, we can see that angle ABC, which is this angle here, again from A to B to C, is 65 degrees. There is another angle that's 65 degrees, angle DEF. So those angles, they have the same measure, they're both 65 degrees, so they are congruent. Alright, notice these other angles that we have here, angle DEB So this angle, DEB, is, we can use just the markings. We don't even have to know the measures to know that angle DEB is congruent to angle E, let's just call it EBC. Okay. And that's, again, we just knew they were congruent because they were marked with those radiuses. Okay. So let's talk about our next definition here. Let me check up on our time here. Actually, we'll save this next part for another lesson. I think this video is kind of going a little long, so we'll save it and we'll finish up lesson 1-4 in another video. So you guys have a great afternoon.